Next, methods of producing induced EMF. How can you produce induced EMF by using different methods? See, E is equal to minus d pi by dt. E is equal to minus L into d pi by dt. That means, if you want to produce induced EMF, the following factors you have to consider. What are they? Induced EMF depends on number of turns. Induced EMF depends on flux, magnetic flux. Again, the magnetic flux depends on phi is equal to Ba cos theta. That means the magnetic flux depends on B value, area and theta. That means orientation. So finally, the induced EMF can be produced by either you can vary the number of turns, either you can vary the magnetic flux, or you can vary the area of the substance, or by changing the angle. By all these methods, you can produce induced EMF. Now, in this class, we will discuss only two methods. That is, by changing the area, you can produce induced EMF. By changing the orientation also, the EMF is produced. Those two methods we will learn in this class. First method, motional EMF. This is highly important. So everybody must learn this question, because in examination simply you will get the question like this: explain motional EMF. Explain motional EMF. That is the way the question will be asked for 3 marks question. Now see. Now first I am taking here uniform magnetic field that is acting perpendicular to the plane of the board. How it is acting? The field is acting perpendicular to the plane of the board. That means into the plane of the board. Here I am taking one rectangular substance M, S, R, N. MS or N is the one rectangular substance which is taken, which is placed perpendicular to the magnetic field. On this rectangular substance, I am taking one more substance, that is PQ of length. PQ of length L is taken. PQ of length L is taken. Now, this is L. The distance between SR and PQ is X. SR and PQ is X. Now, I am moving the length of the substance L towards left with a velocity V. Now, once again, all of you see the diagram. A uniform magnetic field which is acting perpendicular to the plane of the board. In this one, I am keeping a rectangular substance and named MSRN, and one more substance I kept to length of the substance, that is PQ of length L is kept, and it is moving towards left with a velocity V. X is the distance between SR and PQ. SR and PQ. Now see how this flux is changing. Phi is equal to BA cos theta. Here theta, not considering the theta, simply I am taking phi is equal to BA. What is the area? Length into breadth. That means phi is equal to B into L into X. This I am taking equation 1. Next, if the velocity is changing, that means if the conductor is moving towards left with the velocity V, the distance is decreasing. That means area is decreasing. Now that one I can take as a V is equal to minus dx by dt. This I am taking as equation 2. And finally, here I am using the induced EMF is equal to E is equal to minus d pi by dt. In place of pi, you substitute this equation. E is equal to minus d by dt into what is pi value? BLX. Now, if you take common BL, it will be dx by dt, and dx by dt is nothing but V, and finally you will get E is equal to BLV, and finally this is the equation we want. So finally this equation is very important. So once again, and see the derivation and everything. All of you see the derivation and everything once again. See, EMF can be produced by using different methods. What are they? By changing the number of turns, by changing the flux, by changing the area, by changing the magnetic field, by changing the orientation, EMF can be produced. Here we are discussing two important methods. First method is changing the area method, and second method is changing the orientation of the method. Now see, first method, it is motional EMF. In this motional EMF, the uniform magnetic field is applied perpendicular to the plane of the board. Here I am giving one rectangular substance, namely MsRn. In this one I kept one more length of substance is L. If it is moving towards the left with the velocity V, the distance between SR and PQ is X. If I am moving with one, X is changing, area is decreasing. Area is decreasing means definitely EMF will be produced. First, the magnetic flux linked with the substance is given by pi is equal to BA cos theta. If theta is not mentioned, means remove that one. Pi is equal to B into A. What is area? Area is nothing but length into breadth, that is Lx. Next, if it is moving towards the left, distance is decreasing. The velocity is nothing but change of distance. Rate of change of distance is nothing but V is equal to distance by time, that is V is equal to minus dx by dt. V is equal to minus dx by dt. Then later I substitute this one in the laws of electromagnetic induction, Faraday's laws of electromagnetic induction. E is equal to minus d pi by dt. Pi value BLX. BL is common, it will be dx by dt. Dx by dt is nothing but velocity, and finally I got induced EMF is equal to BLV. Next, induced EMF in a conductor. Induced EMF produced in a rod, rotated in a magnetic field. Induced EMF produced in a rod rotated in a magnetic field. Once again I am taking uniform magnetic field, which is perpendicular to the plane of the board. Now here I am taking one conductor of length PQ, of length L. It makes an angle theta. If it is rotating with angular velocity omega in anti-clockwise direction, Now in such a condition, see, if the rod is, if I am taking a rod of length PQ of length L, if it is rotating in anti-clockwise direction with angular velocity omega in a perpendicular magnetic field, because how the field is acting, it is perpendicular, it is acting perpendicular to the plane of the board. It makes an angle, it is one position, this is the new position, it makes an angle theta. Now in such a condition, area is nothing but half into what is this area? This triangle area, half into base into height. Base value L. Suppose if I am taking x, here theta is equal to x by L, x is equal to L into theta. Now you can substitute L into theta, and finally area is equal to half L square theta. This is equation 1. This is equation 1. And next we can use induced EMF formula. Next we can use induced EMF formula, that is phi is equal to BA, phi is equal to BA. Now B into area is given half into L square theta, that is half B L square theta. This is equation 2. Now magnetic flux linked with the rod is given by half BL square theta. Now this induced EMF is given by E is equal to minus d pi by dt. E is equal to minus d by dt into half B L square theta. If it is half B L square, if it is taken out, it will be d theta by d theta. D theta by d is nothing but omega. So finally, we will get E is equal to half B L square omega. So this is the induced EMF produced in a rod rotating with angular velocity in a uniform magnetic field. We can get this equation. So once again, let us see the explanation part. Induced EMF produced in a rod rotating in a magnetic field. This is the magnetic field which is applied perpendicular to the plane of the board. Next, consider a rod of length L which is rotating with angular velocity omega. It is initial position, it is the final position, x and angular displacement theta. Now the area is given by area of the triangle half into base into height, half into base value L, this x value L theta. Finally area is given by half L square theta. Now if the rod is rotating, area is changing, orientation, then that is the reason flux is changing. Flux is equal to BA, A value L square theta, finally you will get half BL square theta. And later I substitute the value here, and finally I got E is equal to half BL square omega.